Final value theorem. Final value theorem are one of the most important theorem of Laplace transform. This states that limit t tends to infinity f of t equals to limit s tends to 0 s into f of s. Function value in time domain at t equals to infinity is equal to Laplace transform of that function multiplied with s and put s equals to 0. These two values are equal, and as usual Laplace transform of f of t is this f of s. F of t Laplace transform is f of s. Conditions. Some conditions. Poles of denominator of f of s must have negative or zero real part. Denominator of f of s. F of s is generally a transfer function of a system, and this type of function are represented in this form. And poles. What is poles? Poles is the roots of denominator of that f of s. This function having root -3 and -7. These are negative. Real part of roots are negative. F of s. Another form of f of s may be s plus 3. Let us consider s into s plus 2j plus 3 into s minus 2j plus 3. Roots of this function are s equals to 0 and s equals to minus 2j minus 3, and another, that is conjugate root, is plus 2j minus 3. Here real part of roots are here 0, -3 and -3. So final value theorem are applicable on this type of function. Let us consider a function f of s equals to s plus 3 by s minus s plus 2j minus 7 s minus 2j, because the conjugate form minus 7. Roots of the denominator polynomial of this function are, that will be minus 2j plus 7 as well as minus 2j plus 2j plus 7. These two are conjugates because imaginary part have negative signs and this real part have positive sign. So these functions are not applicable to verify the final value theorem. So because the real part of roots of denominator is positive. This is stated here. Now poles of f of s must not be in the right half of complex frequency plane. Complex frequency plane. Complex frequency planes are this plane. Sigma j omega, that is real part, real axis, imaginary axis. If this is the axis of 0, right hand side is called right half plane, this is left half plane, right half plane. Poles of denominator of the f of s. Poles of denominator of f of s, these are must not be in the right half of s plane. The poles must be in the left half plane. Here, this may be pole, this may be pole, this may be pole, but no any pole should be on the right half plane. If f of s, denominator of f of s, have pole in the right half plane, then not applicable. Not applicable. It may be on the imaginary axis, it may be on the left half of s plane, but not in the right half of s plane. This. Now an example. F of t equals to 3 into u of t plus 2 e to the power minus t. This equation can be transformed into in the frequency domain as f of s equals to 3 into u of t is converted to 3 by s plus 2 by s plus 1. This is a delay operator in the time domain, and frequency domain it is delayed, advanced by 1 unit. And this is written as 5s plus 3 by s into s plus 1. if we want this function in the time domain at time is equals to infinity, what will be this value? This value can be calculated by final value theorem. According to final value theorem, f of t tends to infinity equals to limit s into fs, s tends to 0. That is, here we put s equals to 0, this will be 0, and this will be multiplied with, s means s into 5s plus 3 by s into s plus 1. This s will be cancelled. Limit s tends to 0. Now we put s equals to 0. 5 into 0 plus 3 by 0 plus 1 equals to 3. Hence, function value at t equals to infinity is 3. Thank you.